All right. Now, so when we have a circles, we got something uh is we have a center of a circle and we have a radius. So basically, if you say put in a thumb you put something here in the middle, put a string out, and as long as then you're going to let's say you put something in the ground and you have a string and you just grab the string and you just walk around the center of circle, you'll make a circle. So that's for a circle, we got the center of the circle, and we also get the distance from the center to the circle here is a radius. We call that radius. Okay. And then if we have some line go across here on the circle, and this is called chord. Now the longest chord is the one right going through the center of the circle. And this chord, this chord is called diameter. Now the diameter just basically cut the circle into two equal half. So this is semicircle. The other is also semicircle. And people actually found the relationship between the diameter and the circumference, which basically is the parameter of the circle. And they found that they are always a constant. So let's say this is a circumference. Let's call that C. And we got a diameter divided by D. And people found that no matter how hard, how big or how small the circle you make, the ratio is still the same. It's constant ratio. So it's kind of amazing importance property of a circle. So people later on mathematicians just call this ratio pi, which is actually a Greek letter. And so now our circumference is equal to pi times our diameter. So you can see that if we times d on both sides, and it's d canceled. So circumference is pi times d. And we also know that the diameter is twice a radius. And you can see from here. And if we cut the diameter, we do this side is one radius, the other side is another radius. So then we can write this as pi times 2r. Then we write as 2 pi r. So that's our first formula for the circumference is C equal to 2 pi r. Then what about the area? Area, we got a circle. So people found that what happens if we're going to cut them into slices? Okay, so cut them very thin slices and then put them together. We got something like this. There's the one slice. There's another one. There's another one. And there's another one. So also on the top slices. And eventually what you got here is, we know it's very much like a rectangle. And from here to here is pi r, because half the slice is put down here, half is put on the top. And the height here, of course, is just our radius, r. So therefore, our area for a circle is the base, which is pi r, times height. So now we got pi r squared. And so now we get another formula for circle is area is pi r squared. Yeah. Okay. Are we good here so far? Thank you, Grayson. Thank you, Mason. Thank you, Roger. Thank you, Mia. Okay, now let's actually do some practice, do some exercise. So we know there's two formulas. One is the circumference, which basically is the parameter. We also know the area, and that's the two important things we need to know. So the circumference is 2 pi r. The area is pi r squared. Now, pi is an interesting number. Pi is something, it's called irrational. So if you want to write out pi, it will never stop and keep going. And there's no repeating. So, and I don't know, some people can memorize pi up to hundreds, and some can go to like tens of thousands. Yes, but they will never stop. It's keep going. Okay, so that's why it's better to just use a letter. And also we can approximate. Sometimes, very often we just use 3.14. And there's actually another approximation is 22/7, which is better than this one. Um, um, by better, I mean that this one is more accurate. Okay, so let's say have a circle. We got R is 5. What's the circumference? So the circumference is 2 pi r, 5, and just 10 pi. Now, if we want to be accurate, we just keep pi. And sometimes they will want us to make approximation, and they will tell us to what digit they want us to round the answer to. Now, if you don't say anything, then we just keep at pi. So now area then is pi r squared. Pi r is 5. That's 25. So 25 pi. So we just write like that. Good. Good job, Mason. And Grayson, Mia, and Roger, are you guys good? So we basically just plug in, we know the formula, and we just plug in if we know R, we just plug in R. So if the R radius is 5, then for this type of circle, then the circumference is 10 pi, and the area is pi r squared, which gave us 25 pi. Okay. Roger and Mia, can you hear me? Hello? Okay. Are you good for this problem?
Yes.
Okay, now I give you something to try. Okay. You type in. Now our R is 4. What is our circumference? What is our area? For the pi, just write as pi, okay? Good job, Mason. Yeah, if you don't know how to do that, this one you can type IDK. Yeah, we're not going to approximate. We just keep at pi. Yeah, we don't approximate unless like when we are instructed to. Good job, Mia. So we just keep pi. Good job, Grayson. Uh, be careful with area. Area is so we know the circumference is. Oh, why do I got this? Oh, okay. All right. So our circumference is 2 pi r. Our r is 4. So 2 times 4 is 8. So it's 8 pi. Now our area is pi r square is 4 square. So we got 16 pi. Very good. Now let's see our R is 7 and see what you got.
Are you talking about the homeschooled kids? Yeah.
Are you okay, Grayson?
Yes. Sorry. Thought I was on mute.
Good job, Mason. Good job, Mia. Okay, Roger, do you need more time? Okay, so Roger, what's your answer on this one? Okay, so our circumference, we know look at our formula. Circumference is 2 pi times r is our radius. Our area is pi r squared. So circumference is 2 pi. Our r is 7, so plug that in. That 2 times 7 is 14, so we can simplify it to this. And our area is pi r squared, which is 7 squared. And 7 squared, 49, so we got 49 pi. Okay, are we good here? Thank you, Grayson. Thank you, Mason. Thank you, Mia. Thank you, Raji. Okay, I'll give you one more, okay? R is equals to, let's see, 9, and see what you got. Good job, Mason. Good job, Mia. Good job, Audrey. So what is the area? Yeah, good job, Grayson. Okay, Rodri, what's the area? Good job, Rodri. And Grayson, what's the area you got? All right, so let's see. Our circumference is 2 pi r, which is 9. 2 times 9 is 18, to get 18 pi. Our area is pi 9 squared. We know 9 squared, 81, so 81 pi. Okay, are we all good on this one? Thank you, Grayson. Thank you, Mason. Thank you, Mia. Thank you, Roger. Okay, so now we're going to looking at something called solid figures. So we did area and parameter. Those are two-dimensional shapes. But a lot of things we see in real life, they actually are three-dimensional. They're called solid figures. And of course, the simplest one we see is called cube. And we got all sides are exactly the same. That's why it's called a cube. And so now, how do we measure the volume of a solid figure? So, and just like when we measure in an area, when we measure area, we need unit square. We just say, okay, let's say if we have unit square, this is a 3 by 5, and each one is 1 by 1. That's called the unit square. We use a unit square as our measure. So we just want to see how many unit square we can fit into this 3 by 5 space, two-dimensional space. And we can easily figure it out. Yeah, 3 times 5, 15. We got 15 of those fit in. Now, how do we figure out volume of solid figure? We just need to figure out how many units cube. Unit cube is 1 by 1 by 1. So all sides are 1. Just like in 2-dimensional, all sides are 1. And here's 3-dimensional. So we got the width, length, and height. So 3 things, but they're all 1. So we want to see how that can fit in. So therefore, if this is 3 by 3 by 3, then we know that if you can see here, we can have 3 layers. The first layer, just like we did on the area, the first layer, we got 9 of those 1 by 1 by 1 cubes. Second layer, we got 9. Third layer, we got another 9. So therefore, we got 3 times 3 times 3. And so we can say 3 times 9 is 27. 3 times 3 times 3, that's also 27. So now we have this formula for a cube is the length, width, and height. So our formula is right as length times width times height. So this one just basically saying how many unit cubes we can fit into this solid figure. In terms cube, that's easy because all sides are the same. Saying like the L is equal to W, length equal to width, equal to height, equal to the same thing. So we become S cubed. Okay. Very good. And okay. So now from that, then we're looking at something called prism. Prism is we call this base, and prism is something like this. Yeah, you can see that it's actually made, if you look at all the faces are rectangles. So use that make kind of like a box. That's called, in this case, is called a rectangular prism. Because the base here is actually a rectangle. And this one we got width, length, width, and height. So the volume is simply length, width times height. And now we can have different kinds of kinds of prisms. This is called rectangular prism. Then we could have something, if something like the bottom is a triangle. Okay, and okay, so now this is called the base is a rectangle. Oh, I'm sorry, a triangle. This is called triangular prism. Now the volume is the base area. In this case, is the area of the triangle. We can say base area, just write as area times the height, which is same kind of similar to this one. This is a length times width, basically is the area. So normally we depends on what kind of base. We could have different kinds of prisms. Like here, the base is a rectangle. We could have the base as a square, and then that's a square prism. Then we have the base area is a triangle, so we get triangular prism. We can also have something like if the base could be say pentagon. is something like this. Then we have okay. Then that's still a prism, but in this case, the base area, the base is a pentagon. So we call that still using this formula, the base area times height. And okay, let's do a couple of practice here. Just looking at the prism, the rectangular prism. So we got rectangular prism here. This is 4, this is 3, and this is 5. What is the volume of this triangular prism? Good job, Dorothy. Good job, Mason. Good job, Mia. Grayson, you good? Oh, we got that. Okay, so we have this prism, pretty straightforward. We just find the base area, which is 12 times height. Then we got 60. And now, then we got something similar to that, but our base area actually is a circle. This is called a cylinder. Now, the idea is still the same. The volume is a base area, which is a circle, times the height. Now, for the circle, we know need to do R. So the volume here is the base area times height, but we know the area is pi r squared. So we have this formula, pi times r squared times height. So this is the area, and this gives you the third dimension, the height. So we got a volume. So if we have a cylinder that the r is 4 and the height is, say, 7, then our volume will be pi r squared will be 4 squared times height is 7. So that's pi and 16 times 7. 16 times 7 is 42. 1 times 7, 7 plus 4, 11. So is 112 pi. Good? Okay. Give you a practice. Let's see, we got the cylinder. Our R is 5, our height is 3, and see what you got. Good job, Mason. Good job, Roger. Good job, Grayson. Yeah, Mia. Hello, Mia. What's your answer? Hello, Mia. Do you need help? All right. Let me see. Okay, what's the answer to this problem? Yeah, if you don't know, you can just type IDK, okay? Very good. Yep. So we know we basically our volume is the base area times height. So it doesn't matter if it's cylinder or a prism, it's always base area times height. Just the base can be a different, could be a square, could be rectangle, could even be a parallelogram, but it's always a base area times height. I'm going to give you another one. If R is, say, 7, our height is 5, what will be the volume here? John Mason? Good job, Roger. Good job, Mia. Yeah, Grayson?
1 second.
Okay. Very good. Very good. Okay. Now I'm going to give a different uh prism. Now, in this case, the base is a right triangle. And it's 4 and 7. This is a right triangle here. And make a triangular prism. And our height is 6. So what is the volume of this triangular prism? So still base area times height. No, this is volume. Volume is the base area times height. Good job, Mason. Well, right now we're doing not cylinder anymore. Okay. Um, make sure. Yeah, make sure what is area that's triangle. Area triangle is half base times height. So calculate the base area, then times the height. Yeah. If you don't know how to do this one, you can just type IDK. Um, Mia, do you need more time? Yeah, Grayson and Mia, what's your answer?
Sorry, 1 second.
Mm-hmm. Yeah, make sure our area formula is half base times height. Okay, so it could be it could be off without multiply the half. Okay, so half base times height. We know the base here is 7. Our height is 4. So half times 7 times 4. And that give us, that divide to the 14. Now the volume is area, which is 14 times height. Height is 6. So therefore, we got 84. And that's our volume. Okay, are we good here? Thank you, Mason. Thank you, Mia. Roger, are we good here? All right. Okay. I'll see you guys next time. Okay. Next week.
Bye.
Bye.